All right, so as I told you guys the other day in class, I need you guys to finish your notes for section 2 of chapter 11. I remember your objectives for that section were to talk about natural selection and how it affects the distribution of traits in a population. So we had these ideas: directional, stabilizing, and disruptive selection. Right? You need to be able to differentiate between those three things. And so to start with, we talked about a normal distribution, that bell curve, right? So you should have that in your notes already. But again, it's just a distribution that looks something like this, right? There should be more average than the extremes in a graph, right? With the number of individuals going up and down, right? Maybe there are some short people in your classroom. Maybe there are some tall people in your classroom, but more likely than not, there are more average height people than anything else. And so you have a mean in there, everything. Our selection acts on that normal distribution. So our first example was just this directional type selection where you had a number of organisms, you had some trait that exists in a continuum. So you had the bacteria that had a very low resistance to the antibiotics, and you had those highly resistant bacteria as well. And we talked about how because of our use of antibiotics, a lot of the bacteria that would have had low resistance to any kind of drug, right, like penicillin, have been wiped out. And since they've been wiped out, there's actually a new distribution here. So I'm using a different color. You might use a dotted line. I'm doing both things right now, obviously, but if you don't have a different color, you just use a dotted line. Right? Directional selection causes my mean to shift towards one side or the other. So there are more bacteria now with high resistance to bacteria, or to penicillin, than there were 100 years ago before we started using penicillin. So it's one of the byproducts of using that as medicine, which again is why you guys definitely need to take every one of those antibiotics that's prescribed to you by a doctor, so you don't breed condition, so you don't create a condition where lots of highly resistant bacteria are going to multiply in your body. But directional selection was just one type of selection. There's also two more types that you guys need to deal with. So there's this stabilizing selection. So again, we always start with a normal distribution, so you just need to draw that in there, that normal bell curve. It doesn't have to be perfect, but pretty close. I have a new set of traits here to deal with, and this is going to be an example from the book. We're going to be talking about gall flies and the gall size example in the book. Now, I copy and pasted this picture from the book so that you guys could see it and understand what it's actually talking about. Basically, this fly lays its eggs in the stem of a plant, and that stem becomes enlarged, and that is actually what we're talking about when we're talking about that gall. So that gall is that blown up portion of the stem of that plant, and that ball there that you see, that gall, could be really large or it could be really small, right? So sometimes those flies lay eggs and you have a very small gall size, which would be on this end of the continuum. Sometimes you have very large galls. And it matters whether they're big or small. Right? Again, those flies want their offspring to survive, and that gall size is our contributing factor here, is the main issue with this example. Right? If that gall is very large, right? So if that gull is really, really big and very noticeable, oftentimes woodpeckers will find those and eat all of the offspring inside of that gull. So there's a selection taking place here because the woodpeckers are eating all of the offspring that are in larger sized gulls, which selects against that larger size. So you would think that those gulls would get smaller and smaller and smaller, just like in that other example. If you're eliminating one extreme, it should push that mean in one direction, towards the left in this case. But it turns out there's actually two selective forces here. Aside from woodpeckers attacking those gulls, there is also the possibility of having a wasp lay its eggs inside of the gull in a parasitic fashion where its babies will actually eat the larvae of the fly to survive. So you have not just one selectional force, you have two. So I have wasps on this side that are actually not laying their eggs in the larger sized gulls, because if they lay their eggs in the larger sized gulls, then the woodpeckers eat their offspring just like the flies. So the wasps are only laying their eggs in the very, very small gulls, right? They're noticeable enough that there should be some larvae in there for their offspring to survive off of, but they're not so big that they know the woodpeckers are going to get to those. So you have selection from both sides in this case, eliminating the small gulls and the larger gulls, because those are the offspring for the flies that don't survive. And if they don't survive, they're not going to pass on that trait. You're not going to end up with that size of gull anymore. And as a result, you see a different kind of selection, right? On this side, right, it's trying to push this way, but it can only go so far because you had the pressure from the woodpeckers on the other side. So what actually ends up happening is more and more individuals end up with that median trait, the middle-sized gulls, right? So I have to make this curve skinnier and taller than it was before, right? I did kind of use two colors because there's two reasons for this, right? It's basically two directional selections happening at the same time, squeezing this distribution until it's tall and skinny like the dotted line, right? Dotted / colored line that I drew. But that's called a stabilizing selection because it makes that average the most frequently occurring trait. So those average size, those medium sized gulls are what are being selected for. Because if it's too big, the woodpeckers get it. If it's too small, the wasps are going to lay their eggs in there. So it's got to be somewhere in between.